Hello friends, today we will discuss about these two problems. In previous class, I have only discussed how to calculate the Thevenin voltage and Thevenin impedance for a circuit consist only DC energy source. But today I will discuss how to calculate the Thevenin voltage and Thevenin impedance for a network which consists AC energy source. So this circuit contain a one AC voltage source and two resistors and three inductors, and this circuit consists one AC voltage source and two inductor, one resistor and one capacitor. Okay, so to calculate the Thevenin impedance and Thevenin voltage, you have to get idea about the complex number. If this is the complex number x equals z equals to x plus jy, where x is the real part and y is the imaginary part, and this is the real axis, this is the imaginary axis, then this is the complex number z. So this is the theta which make angle with the real axis, so it can be described in rectangular form. This is z equals to x plus jy. In polar form it is z equals to r theta, and exponential form z equals to r j e to the power j theta, and in trigonometric form it can be written as z equals to r cos theta plus j sin theta. Okay, so if I write the complex conjugate form, then it can be written as z star equals to x plus jy, and z star in polar form equals to r minus theta, and exponential form equals, it will be r e to the power minus j theta, and trigonometric form it will be r cos theta minus j sin theta. So how to calculate the multiplication of complex number? This is the multiplication, and this multiplication is in rectangular form, and this multiplication is in polar form, and this multiplication is in exponential form. And you have to also know how to divide the complex number. Suppose this is the rectangular form division, and this is the polar form division, and this is the exponential form division. So this is very important to calculate the Thevenin impedance for a circuit which consists several number of resistor, inductor and capacitor as well as AC energy source. So this portion you have to write in your notebook. Now I will start the problem number 1. So problem number 1. In earlier class I have already shown that VTH will be VOC. That means the open circuit voltage across the open circuit terminal will be the VTH, okay, of the circuit consists independent energy source. So you have to calculate the open circuit voltage of this network. Okay, so how to calculate this? Now if I take, this is a one node, suppose this node is x, this node is x. Now this inductor is connected to a open circuit node. This is the open circuit node. So current through this inductor will be 0. So current will pass in this direction. Okay, no current will pass through this inductor is equals to 0. So we can easily calculate the open circuit voltage across this terminal is equals to the voltage across this branch XB. So what will be the VOC? So VTH equals to VOC can be written as the voltage across the XB branch. Okay, this is X node and this is B node. So voltage across this branch will be the open circuit voltage or VTH, because this inductor, current through this inductor is 0, because this inductor is connected to a open circuited terminal. That's why there is no current flowing through this inductor 2 Henry. So this voltage across this branch can be easily calculated by voltage division rule. So this is one impedance and this is another impedance. So this impedance, suppose Z1, can be written as 2 plus J2, and this impedance Z2 can be written as 4 plus 6J. Okay, this is 4 plus 6J. So using voltage division rule, we can written as V voltage across XB is equals to the Z1 Z2 divided by Z1 plus Z2 into 100 0 degree. Okay, so using voltage division rule, we can write that this is the Z2, so Z2 divided by Z1 plus Z2 into multiplied by the voltage. So if I put this value of Z2 is 4 plus 6J, and it is Z1 is 2 plus 2J, and this is 4 plus 6J, and it is 100 degree. So if I write that this way, 4 plus 6J, and this is 6 plus 8J multiplied by 100 degree. Okay, so you have to transform it into a rectangular form, this one and this one. So if I transform it into a rectangular form, polar form, then it will be 4 square plus 6 square, this is the R, into theta. Theta means it will be tan inverse 6 by 4, and this can be written as this is the R, 6 square plus 8 square into theta. Theta means tan inverse 8 by 6, okay, into multiplied by this. Okay, so what will be this value of this? This is 16 and this is 36. So 36, if you calculate this value, then it will be 7.21, and if you calculate this value tan inverse 6 by 4, it will be 56.3 degree. Okay, and this is 30, this is, so it will be 10, and if you calculate this value of tan inverse 8 by 6, it will be 53.1 multiplied by 100 degree. So next step is, from this point the division is 7.21 divided by 10, so it will be 0.721, and this angle will be 56 minus 0.3 minus 53.1, so it will be 3.2, so it will be 3.2 degree multiplied by 100 degree. So 100, if you multiplied 100 by 0.721, so it will be 72.1. This angle will be 3.2 degree. So Thevenin voltage of this network is 72.1. This angle is 3.2. So you can calculate this VTH in rectangular form. This is the polar form. You can write in the trigonometric form. So this is the very easy process. So this is the Thevenin voltage of this network. Now you have to calculate the Thevenin impedance. How to calculate this Thevenin impedance? So Thevenin impedance is equals to the equivalent impedance seen across the open circuited terminal by replacing all the voltage source by their internal impedance. So to calculate the Thevenin impedance, you have to replace the voltage source by their internal impedance. So this is the voltage source, and this voltage source have zero internal impedance. That's why you have to short circuited it. So this is voltage source, so you have to short circuited this voltage source because this voltage source have zero internal impedance. So you have to calculate the ZTH. So ZTH will be the Z equivalent seen from this open circuited terminal. So if you see this network from this 2 point AB, then this is one and this is the another portion. That means Z2 and Z1, these are parallel. So ZTH equals to this 2J is in series with the Z1 and Z2 are in parallel. This and this portion are in parallel. So this is Z1 parallel Z2, and these 2 Henry are in series with this resultant. Okay, so the equivalent impedance seen across this terminal is equals to the parallel form of this Z1 and Z2, and this will be series with this equivalent resistance. Okay, so this is so it can be written as 2J plus Z1 is 2 plus 2J parallel 4 plus 6J. Okay, so it will be 2J plus, and parallel form is equals to the multiplication divided by summation. So it will be multiplied form 4 plus 6J, and this is the division summation. So 2 plus J plus 4 plus 6J. So it will be 2J plus, if you multiply this 2, this it will be 2 4, so it will be 8, 2 6, it will be 12J, 2 6, so it will be 8J, 2 and 6, it will be minus 12, because j square equals to value of j is root over minus 1, so it will be 1, so it will be minus 1. That's why if you add this value, so it will be 6 plus 8j, so it is 2j plus minus this is 12, so this one 6 8 12, so it will be 20j 8 12 8 12. Okay, so it can be written as 20j and this is will be minus 4, so it is 6 plus 8j. So now you can write this from in this way, so it is 6 plus 8j, so you have to multiply this with this portion, so it will be 12j and it will be minus 16 plus it is 20j minus 4, so it will be 16 and 4, so it will be minus 20, and this is 12, this is 20, so it will be plus 32j, so it is 6 plus 8j. This is the form 20 plus 30j 6 plus 8j. So you can write this, if you take common from this upper portion and from this lower portion, so it will be minus 10 plus 16j and it will be 3 plus 4j. This is the rectangular form of ZTH. Now if you convert into it into a polar form, then it can be written as this is the minus 10 plus 16j multiplied by 3 plus 4j divided by 3 plus 4j. This is minus, okay, this is minus, so it will be 3 plus minus 4j, so it will be 3 square and plus 4 square, because a square minus b square, but minus j square equals to minus, that's why minus is equals to plus. So from the upper portion it can be written as minus 30 plus 40j and this is plus 48j and this is minus, so minus plus, so 64. So from this equation you can write that this will be 25 and this will be 34 and this will be 88j. So if you calculate, then this is the rectangular form of ZTH. If you calculate in polar form, so it can be written as, this is the rectangular form, okay, so it can be written as 25 plus 88 divided by 25J. This is the VTH.